I would like to present my final project, Dating Agency Recommender System. Users of online dating sites are facing information overload that requires them to manually construct queries and browse huge amount of matching user profiles. Building a recommender system can help to improve user experience of dating site users and lead to a high user satisfaction. Data for the project was taken from the following source, and the file is quite large to process, so I have to reduce the file, and I took 1000 users in order to run the code quicker. File includes 3 columns: user ID, candidate ID, and candidates ratings. Rating distribution is shown on the graph, and as we see, 10 and 1 are the most popular ratings. This way, users try to clearly indicate candidates they like or they don't. Project has the following structure. So it's data exploration, first step, then constructing top-end recommender using simple user-based and item-based collaborative filtering. Then I'm moving to more complex KNN recommender algorithms and selecting the best one using cross-validation. Then I measure coverage and diversity of the selected best KNN recommender algorithm. And last step, where I'm implementing matrix factorization techniques such as SVD method, and I'm going to tune it and select the best parameter using measuring the RMSE score. So the first algorithm is basic user and item-based collaborative filtering. This is a simple top-end recommender, and these algorithms do not make any rating predictions. These algorithms are being constructed in the following way. First step is candidate generation, then candidate scoring, then sorting the candidates by the final score, and finally candidates filtering, where I apply some similarity score thresholds or and also minimum rating threshold, basically this is top 10 recommendations for the 10th user, or just top 10 candidates for the 10th user. As we see, simple item user-based and item-based collaborative filtering algorithm produce quite different results apart from 2 candidates. So basically 2 out of 10 candidates recommendations are similar for these algorithms. The more complex algorithms is KNN recommender algorithms. And KNN recommenders, unlike simple top-end recommender, are not just recommending candidates that people similar to the selected user like, but also they are trying to predict rating for every possible candidate, for every possible user. The performance analysis of recommender algorithms presented on the slide, and KNN baseline the best algorithm because it gives the best accuracy. Here is the top 10 best and worst predictions of KNN baseline algorithms, as it was considered as the best at the cross-validation stage. I have decided to implement that algorithms and calculate its coverage and diversity. And coverage is looks quite high, which is good, but I have applied the algorithm only to the 1000 users. For the full set, it is expected to be lower. Diversity looks quite high, but it's quite hard to judge in isolation with other metrics and without comparison with other algorithms. Matrix factorization techniques was applied, and in particular singular value decomposition algorithm, and it was tuned, and the best parameter was selected in order to improve the accuracy, and it was improved, but not significantly. As we see, there is quite small difference. Conclusions. My takeoffs for that project is that more complex algorithms usually produce better results, better accuracy. But in real life, these algorithms often perform bad. Accuracy is not everything, and it cannot guarantee the success of algorithms application on real-world data. Other performance measures should be considered, like diversity, novelty, coverage, hit rate, etc. We can improve algorithms' accuracy just tuning the parameters. And also, quite important thing that time processing is an issue. Usage of Spark should be considered in the world of big data. So basically, that's it. Thank you very much.